In this video, you're going to learn how you can implement bullet spread and gun recoil in a procedural manner into your game. Hey, Chris here from LlamAcademy, here to help you.
Who, me?
Yes, you. Make your game dev dreams become reality by helping you implement a scriptable object-based gun system with procedural recoil and bullet spread. You can't really talk about just bullet spread without also talking about gun recoil. They go hand in hand, right? The gun is recoiling and that's what's making your bullets go all over the place. Luckily, adding in recoil isn't really very challenging based on the same concept of doing bullet spread. At a high level, what we're going to do today is first implement different bullet spread types. You could have none, where you're always perfectly accurate, shooting straight out of the gun's tip. One with simple recoil, which is what I most commonly see implemented on other tutorials and what I've implemented, and say we're going to pick a random value between negative 0.05 on the X, Y, and Z axis and apply that each time that you shoot. And the third one is a texture-based one. So I don't know if any of you played Counter-Strike, anything like that. You had pretty well-defined patterns that guns would spray at. I'm pretty sure something like this is how that was implemented. However, to implement this using our scriptable objects, we're going to have to make a little bit of tweak to what we've done so far. Usually when we talk about bullet spread, the shorter time you've been holding down the mouse button, the more accurate you are. So my first couple shots usually go pretty straight, and then later on, as I've been spraying and praying, it goes all over the place. So to be able to do that, we need a little bit more information about shooting than what we've been getting so far in the GunScriptable object. So we're actually going to bring everything about shooting into the GunScriptable object, where it's going to have a tick function, much similar to update, that we would expect to be called every frame. Once we know this, we can properly apply that bullet spread, that bullet recoil, and the way the recoil works is really just applying an offset to the gun's forward based on the spread that we've calculated. The final piece of the recoil is, once we've applied the offset, it needs to start slowly coming back to pointing correct, which is also why we need that tick function on the GunScriptable object, so each frame we can start coming back to aiming straight forward. Let's lock and load and get this one started. To make this bullet spread work the way that we need it to, it's important that we have a new gun parent. Our shoulder is actually pointing down, which doesn't work very well for us because then we don't know what's forward. So we need to parent the gun under something that's actually facing to the player's forward. So I'm going to create a new empty game object underneath that right shoulder that we wanted to parent the gun under, rotate it so it's pointing towards the player forward, that's blue facing out, and we'll set that to be the gun parent. I tried to set up all this recoil stuff without this and there's too much math, so doing this really makes the math a lot more simple. We'll start with that new enum, the bullet spread type, change it to an enum, and add the three modes that we're going to have. None, which would mean you're always perfectly accurate. Simple, which is what we've already implemented. And then the texture-based one, which is a cool one we're going to implement today. In the GunScriptable object, we're going to do things a little bit differently than what we did in the last video. In the shoot method here, we're actually doing stuff related to bullet spread, which is really what we're going to put into the shoot configuration. So I'm going to remove all of the code from GunScriptableObject that has to do with calculating the bullet spread and move that into the shoot config scriptable object. Since we're going to have different ways of calculating the spread, it makes this a lot more clean if the shoot configuration, which has all the configurations about that, knows how to tell you what the spread is. You'll notice that I did put in a float shoot time as the spread parameter because we need to know, if we're going to calculate the spread, how long you've been shooting for so we know how wide of a spread to give you. We'll get into how we're going to calculate that in the GunScriptable object in a little bit. And to relieve ourselves of any compilation errors, back in GunScriptable object, we're going to set a Vector3 shoot direction to equal the model transform parent forward plus the spread amount. We'll come back to GunScriptable object in a little bit. Let's go ahead and implement these different bullet spread types and then hook it all together in the GunScriptable object. That way we're not bouncing back and forth too much, it gets really confusing. I'm going to do a little bit of reordering of these variables and set up the key things that we need for our two different bullet spread types. We're going to move the spread to the bottom, add in a public bullet spread type equals BulletSpreadType.simple by default, because that's the only one we've implemented so far. We'll add a header over the spread saying simple spread just to kind of group the different variable types. We'll add another header for texture-based spread, so we separate these two so it's clear if we're going to use one, we don't care about the other value. We'll set a range from 0.001f to 5f with a public float spread multiplier, and we'll set that to 0.1 by default, and a public texture2D spread texture. Let's go into get spread to choose how do we calculate the spread based on these different spread types. At the top, we'll say a vector3 spread equals vector3 0. If the spread type is a simple bullet spread, we'll do exactly what we did before. Else, if the spread type is a texture-based, what we're going to do is, just to make this method a little bit more clean, spread equals get texture direction, passing in the shoot time, and then multiply the result by the spread multiplier. We'll return the spread at the end of this function, so that way we know we either have 0, we have that random range between the spread, or we get, somehow we're going to sample this texture and come up with a spread for ourselves. Now at the beginning I said that we can't really do bullet spread without also doing recoil because it doesn't really make sense to do those separate, right? So if we're going to talk about recoil, we also need to consider how quickly do we return to our original position and how long does it take before we're totally inaccurate with our gun. We're going to call that a recoil recovery speed and a max spread time. I'm not going to put ranges on these because really this is totally up to you. You can set whatever value you want. And a lot of it's going to be tuning to what makes your game feel good. So let's take a look at our simple bullet spread first. How can we implement this? Well, since we're getting the shoot time passed into us, let's pretend like we know how that's going to work. What we can do is a vector3 lerp from 0 to this spread range that we've defined based on that shoot time over the max spread time. That way, the longer we've been shooting, the more random we get up till we're sampling the full range of this spread. Perfect. We can then do the cool texture-based spread. At a high level, the algorithm that we're going to use is we're going to sample a point on this texture at the center. And the longer we hold down that mouse button, the longer we're shooting, we're going to sample a larger and larger square, so a larger sample set of the pixels of this texture. And we're going to use the grayscale value. You can use any value you want, RGB, A, even, doesn't matter. Where in our case, since we're using grayscale, the more white the pixel is, the higher likelihood it is that we will select that pixel. We're using a random weighted algorithm based on the grayscale to choose the pixel that we want to use as our random sample. Once we know that pixel, we're going to calculate the direction from the center to that pixel, map that to world space based on the player's current position and forward, and use that as a way to apply offset to the gun to add our recoil. Let's go ahead and start implementing that now. We'll define a vector2 half size to be the spread texture width divided by 2 and the spread texture height divided by 2. We'll calculate the half square extents. And that's going to be the square that we're sampling. How large is that going to be based on that shoot time? So we're going to go from, I put 1, we're going to change that in just like 2 seconds to be 0.01. From 0.01 to the half size x, and we're going to clamp that lerp from based on the shoot time over max spread time just like we did above. We're then going to calculate the min x and min y. It's going to be the bottom left coordinate for this square. So we're going to take the half size x minus half square extents and the half size y minus the half square extents. That'll give us the bottom left corner since we're sampling from the middle pixel of this square that we're going to sample from. We're then going to sample that rectangle from the texture with color array sample colors equals spread texture.get pixels from the min x, min y, passing in half square extents times 2, which would give us the full square that we want to sample. So it's going to read half square extents times 2 to the right and up that whole block of pixels, and that'll get returned to us in this color array. I don't actually care about the colors, I care about the grayscale, so we're going to do float array colors as gray equals system.array.convert all, passing in the sample colors, and then a delegate to say color arrow color.grayscale, which will just give me a value from 0 to 1 based on how white that pixel is. Black being 0, white being 1. Then we're going to implement the weighted random algorithm. So we need to know the total gray value. We're going to get the total gray value by summing all the colors as gray. The sum comes from system.link. We're then going to choose a random value from 0 to this value. We're then going to iterate over all the colors as gray, subtracting out the current index from gray and checking if gray has gone equal to or lower than 0. If it has, then we know which index that we want to choose. Once we know the index of that color array that we have picked, what we can do is map that back to the 2D pixel coordinate on the texture that was sampled. We can do that by doing int x equals min x plus I modulus half square extents times 2. That'll give us the column that was selected, the X value. We can get the Y by doing min Y plus I divided by half square extents times 2. There's some pretty tricky math, but it works out. Now for this section, I recently did a video about how to sample a texture and the ins and outs of this algorithm. So if what I'm talking about here in this function doesn't make sense, go check out that video, link in the description, card on the screen. Once we know the X and Y coordinates, we can make a target position from those two and calculate the direction by doing direction equals target position minus the origin point and then dividing that by half size X. That'll give us a direction vector using the center of the texture as the origin towards the point that we selected. Now we have the ability to have two different bullet spread types, simple and texture-based, both that will respect the shoot time passed in and choose a random value closer to the origin point or closer to 0 when that shoot time is low. And the closer we are to the max spread time, the more wild it will be. I want to give a quick shout out to all of my Patreon supporters. Without you, this channel would not be possible. At the phenomenal tier, there's Andrew Bowen and Andrew Albright. And at the awesome tier, there's Gerald Anderson, Autumn K, Matt Parkin, Ivan, Paul Berry, and Rulin. You can show your support at patreon.com/LlamAcademy to get your name up here or a voice shout out starting at the awesome tier. Thank you all for your support. I am so grateful. We'll open up the GunScriptableObject again to actually shoot and pass in that shoot time. So we'll see in shoot that we already have that last shoot time, but to know how long we've been shooting in between, if you've started clicking, stop, and then start again, we're not going to know because we only have the last shoot time. So we're going to need a couple new variables, the initial click time and the stop shooting time. To know when we stopped shooting, I'm going to also need a Boolean saying that we wanted to shoot last frame. I'm going to define a new public void tick that accepts a bool wants to shoot. The expectation of this GunScriptableObject is now that every update we will call tick, regardless if you want to shoot or not, telling us if you do or not. That way the GunScriptableObject can be fully responsible for handling recoil, shoot, and understands what the user is doing. If we want to shoot, we're going to call shoot and set the last frame wanted to shoot to be true. If we don't want to shoot anymore and the last frame we did want to shoot, we're going to set the stop shooting time to this time and set last frame wanted to shoot to be false. So now we definitely can know when we started shooting and when we stopped shooting. The next thing we need to know is when did the user start clicking? We can tell that by knowing if time.time minus the last shoot time minus the shoot config fire rate is greater than the time.delta time. We can take the current time, we can subtract out the last time that we shot something and subtract out the rate of fire. If that gives us more than a single frame delta, then we know we have let go of the mouse button for some period of time and we should start shooting fresh. The most naive implementation here would just be to set initial click time equal to time.time. But that would give us this where as soon as I let go and I start clicking again, it's perfectly accurate. So that's not great. What we can do instead is calculate how long have we been holding down the mouse button for the last time that we were shooting. To do that, I'll do a float last duration equals mathf.clamp from 0 to the stop shooting time minus the initial click time, clamping it to at most be the shootconfig.max spread time. So this would tell us from the last time that we were shooting, what was the total duration of that spray, where we're capping it at the max spread time because at that point it doesn't matter if it's higher or not. We want it to come down from there. I'm then going to define a lerp time to equal shootconfig.recoil recovery speed minus the time.time minus stop shooting time. So we're calculating how long has it been since we stopped shooting until the current frame, and we're subtracting from the recoil recovery speed that value. We're taking all that and dividing it by the recoil recovery speed, which will give us a value between the recoil recovery speed and a negative value. If the delta time between when we last stopped shooting and the current frame is larger than the recoil recovery speed, we're going to get a negative number, right? Which is perfect because then we can clamp this to be between 0 and 1 and say initial click time equals time.time minus mathf.lerp from 0 to the last duration and clamp this lerp time from 0 to 1. That means we're going to artificially tell the GunScriptableObject that the initial click time was sometime before this frame, so we can keep that recoil from the last time that they were shooting. So we're not out of the woods yet. We still have to actually do the recoil application. We just now know the time that we can pass to the shoot config get spread. if we hit the above block and we've never shot before, the current time and the initial click time are going to be the same, or if there's been too long of a period between the last time we shot and the current frame. Once we have the spread amount, we can then apply the spread or recoil amount to the model's transform forward by doing model transform forward plus equals model.transform direction spread amount. This is why it's critically important to have that parent pointing forward on the model for our player. We can think of the spread amount as the offset that we're applying from the gun's current transform forward. That makes this make a lot of sense. Finally, the shoot direction can just be the shoot system transform forward because we've now updated the model transform forward to be pointing some direction. You could also probably use model transform forward at this point. You might think we're done, but we don't have a way for this gun to come back to pointing forward. We never implemented that. We will always be applying some kind of recoil and the gun's never going to come back. So that's really why we need tick as well. In here, we can do something very simple. Model transform local rotation equals quaternion lerp from the current local rotation to the spawn rotation, passing in the time.delta time times the shoot config recoil recovery speed. You can use lerp, slurp, either one would work for this. It's really how do you want it to behave. The final thing is in player action, we need to call tick instead of shoot. So I'm going to keep the check if the gun selector active gun is not null and just pass into gun selector active gun.tick if the mouse left button is pressed. There's one more thing we need to do because if we just click play, we'll see that the gun doesn't spawn in the right place. So the IK makes us look kind of crazy. We can shoot behind us and break our arms. That's because we had our right shoulder had a bunch of rotation, so we need to set the rotation probably just to 0, and I think flip the signs of all the spawn points. Maybe we'll set X just to be 0. So now we can see recoil is still being applied. Our gun actually does a little bit of recoiling. And I think the M4 would look a little bit better or showcase what we're talking about a little bit better. So if we select the M4, change the spread type texture based, and in this repository now there's 3 different bullet spread modes, and it's really important on all of these to select read write. If you don't have read write enabled, we cannot sample that texture. So we use brush 1, we'll set the rotation to 0 on all of those and flip the signs of the spawn point of Y and Z. If we click play with these settings, spread amount here is probably too much with how crazy it's going. Maybe the recoil recovery speed could be a little bit higher. I also think 0.05 rate of fire is probably too high. The gun is recoiling as we shoot, applying some kind of random, and if we think maybe this is too accurate still because it's still pretty close to the middle, we can play with a spread multiplier to make it go more wild. What's cool is also at runtime we can change that spread texture and get a totally different feel for how it's going to shoot, which means if you have something like ADS or where you bring the gun up looking down the iron sights, you can have a different spread texture for that versus if you have a hip fire like what we're doing here. We'll stop here for today. That sets us up where we have a framework to implement bullet spread in a procedural fashion on our guns, and we can even implement new ways of doing bullet spread pretty easily. A couple of keynotes about the performance of our texture sampling is, if you didn't watch the other video, when you use get pixels, you probably noticed that returns a color array. Those of you who have done optimization know that this generates garbage. If we only have 1 or 2 players that are using this, it's probably not that big of a deal that we generate this garbage because there's just not that much, and it's much more convenient to get only the pixels that we're caring about sampling back in that array. However, if you're talking about using this kind of bullet spread and you're going to have dozens or hundreds of maybe enemy AI all using the same algorithm, and they can all shoot at the same time, that's probably not going to be okay. You're going to have too much garbage and get stutter in your game whenever the garbage collector comes. There's another function available on the texture 2D that's called get raw texture data, which gives you a pointer to the memory that has already been allocated for this texture in the form of a native array. Problem that you get there is that gives you the entire thing, and so you have to find the right pixels that you want to get out of this very large array. So that's a little bit less convenient to work with, but you will not generate any garbage, which is what you'd be going for in the optimization phase. So as always, whenever you're doing optimization, profile your game and see, is this the right place to optimize? Because it makes your code a little bit less pleasant to work with in that area. There's still a lot more to cover in the gun series, and we're just getting started, but it's already looking really awesome. Make sure you've liked and subscribed. That way you can stay up to date whenever the new episodes of the gun series come out. New videos are posted every Tutorial Tuesday, and I'll see you next week.